This is an example of multiplying numerical expressions with the same basis. 5 to the 8th power times 5 to the 4th power. We can simply take 5 to the 8 plus 4 power, and that would simplify to 5 to the 12th power. If it's an algebraic expression, we're going to say it's y to the 6th power times y to the 8th power. The base is the y. It's okay. The base of an exponent or a power can be a variable. Y to the 6th power times y to the 8th power is equal to y to the 6th plus 8th power, and that would simplify to y to the 14th power. Any questions on that? So one more example here. 3 to the 4th power times 3 to the 2nd power times 3 to the 3rd power. It does not, there can be more than 2 factors. This one has 3 factors. Jeremiah, put the top on that tight and drop it down in your backpack. So to solve this problem, we're looking here, all the powers have the same base, so we are going to we're going to add the exponents. I don't know why I've got an extra blank there. Hold on a second. Let me see if there's something else I wanted to say. I forget. I don't think so. I think that's all I wanted to say. Your word or my word? We're going to go with, it's just all powers have the same base, so we're going to add the exponents. And we're going to put an S on that. We don't need that blank. So this would be 3 to the 4th plus the 2nd plus the 3rd. If these were negatives, it doesn't matter. Jeremiah, put your phone on my desk. What's that? Your phone on my desk. Okay, that's fine. I'll just write your referral. All right, so since these all have the same base, they all have a base of 3, right? We're going to add the exponents together. 4 plus 2 is 6. 6 plus 3 is 9. We keep the base to the 9th power. Now, we are going to simplify these. I think that's what it's supposed to. So we're going to simplify. Oh, my bad. That's what it was there. Simplify the exponents. It's okay. We'll use it this way. So 3 to the 9th power on your calculator. So we're going to use the calculator. For what? You don't just get to pick to go to OFI. No, I can't send you to OFI. That's not an option for me. They don't let you choose to go to OFI.
They be doing that with the sub.
I have no idea about that, buddy. But I'm not a sub, so. All right, so 3 to the 9th power on your calculator. Okay, so now I will call them, and I will write a referral for you cursing me. So, yeah, now, not to OFI, I have to have Student Affairs come get you now. Hey, could you have someone come get Jeremiah Bush from my classroom? He's cursing me. He wanted to go to OFI, and I said, well, I don't get to pick to send you to OFI. Anyway, so then he started cursing me, so I would like for him to be removed from my class. I will write the referral. Oh, I'm so sorry. Oh, I thought you said Miss Green, and I was in a tizzy, so I wasn't listening. Thank you so much. Hey, could you send somebody to come get Jeremiah Bush from my classroom? 310. Sorry, Mrs. Zimmerman. Thank you. Bye. All right, gather up your stuff.
Oh my word.
All right, the calculator. 3. You're going to press the Y to the X button.
19,688.
Did you have to hit equals, Caleb? Eden?
Yeah, he equal. 3 and then the y next.
I didn't have to hit equals on mine when I did it. So let's do 3, Y to the X button, 9, oh I lied, I did have to do equals, 19,683.
Yeah.
So this would simplify to 19,683. That's what it means to simplify the exponent. Not right now. All right. Anybody have questions? Will this work? Shh. Would this work if we had, let's look at this example. If I had 3 to the 5th times 5 to the 3rd, can I just add the exponents there? No. We can't use the shortcut. So we can't use the shortcut there. We could multiply those, but we have to do 3 to the 5th power times 5 to the 3rd power on our calculator, add them together, yada, yada, yada. So the shortcut, this is a shortcut we've learned, it only works if your bases are like. So it does not matter if they're positives and negatives. If all powers have the same base, we add the exponents. We're going to add this word in here. Add the exponents and then simplify the exponent. So this would be 11 to the negative 3 plus 4 plus negative 5. If we use our calculator, did you get negative 4?
Yeah.
But now we're going to simplify. So on our calculator, you're going to enter 4. Go on, Jeremiah. I'll write the referral.
You want to go on the screen?
I don't care where it goes. I mean, I'm just going to write the referral. He was texting on his phone, asked him to put it on my desk. He said no, and I said, well, that's fine, but then I'll have to write a referral. Then he wanted me to send him OFI, and I said, well, I don't just get to pick you to send you an OFI. So then he started cursing me, as he's still doing. So that's why I called him. I was going to let him stay in here, but didn't work out. All right, so 11, we're going to y to the x power. Then you have to hit 4 and then the positive negative button.
You get zeros.
You do. So you get a fraction. You get a decimal less than 1. We know that. We talked about if there's a negative exponent on a number, it's going to be a fraction, right? When you write a fraction as a decimal, you're going to have zeros at the beginning. It's going to be less than 1. So 11 raised to the negative 4th power is 0.000, so 4 zeros. So this equals 0.1234 68301. You do. So let's do a couple of your even problems on your worksheet, so we will go from 25 down to 23, because we'll do some together. So let's look at number, I don't think y'all need my help on 2, 4, and 6, but let's look at number 8. Let's do one like number 8. So number 8 on your homework, so we're reducing your homework, it's negative 4k to the negative third times 6k to the fourth. Thank you. So remember, what is the exponent on negative 4 if you don't see it? 1, right? What's the exponent on 6 if you don't see it? 1, right? So 6 and 4, they're not like bases. We can rearrange this. It's going to be negative 4 times positive 6 times k to the negative third times k to the fourth. So now we're going to multiply these on our calculator. Negative 4, so that's 4 negative button times 6, negative 24. Now, are these like bases? The base is the big number in the exponent or exponential expression or in the power. They're both k's. So we can simplify that by doing k to the negative third plus the fourth power. So that simplifies to negative 24 k to the first power, and we don't need to write the 1 if it's just 1, the first power. Does that make sense? Jacob? Does that make sense, Sam? Make sense, Aiden?
Yes.
Okay. Let's do number 14, and then we're going to move on to something else, something new. So number 14 is 6a cubed b.
Is that a 21? Or is that a just raw?
Here.
Okay, before the negative 2.
Mm-hmm. Please, that'd be great. Thank you. So this is 6a cubed b to the negative second power times negative 4a b to the negative 8th power. So all these parentheses, we don't actually need all these parentheses. This is the same as if we just, this is 6 times a cubed times b to the negative second times negative 4 times a to the first times b to the negative 8th power. We can rearrange. Let's put all the coefficients, all the numbers together. So 6 times negative 4 times a cubed times a. Remember, if you don't see that, that's a 1. Times b to the negative second times b to the negative 8th. These just get multiplied like normal. 6 times negative 4 is negative 24. These have the same basis, so this would be a to the third plus the first power. These have the same basis. This is going to be raised to the negative 2 plus the negative 8th power. I'm going up, I accidentally popped it down. I didn't mean to. So this is going to simplify, right, to negative 24. Something wrong? A to the fourth. And then b, we're going to add those together, the negative 10th. So can that be my final answer? Why not? We would simplify if we could, but these are, that's a B, not a 6, because my handwriting is bad. But we can't leave the negative here. What did we learn yesterday about negatives? We're going to push that to the bottom, right? Anything with a positive exponent stays where it is. Anything with a negative exponent gets pushed to the bottom. So we're going to need a fraction here. Negative 24 is going to stay on the top. A to the fourth is going to stay on the top, but this b to the negative 10th has to get pushed to the bottom and made positive. Caleb, are you not going to follow along with us? Davis? You're not writing what we're writing. I just did 2 of your homework problems for you. Righty. Any questions? So that is problems that are covered in problems 2 through 14. All right, we're going to, sorry?
Right, number 19.
We're going to do some of 19 and some of those in a second, all right? You're actually just going to be able to use your calculator on those, so that's the beauty of that. All right, the next thing we're going to look at is this scientific notation. So scientific notation has to look like this example here. So this is an example of something written in scientific notation. 1.8 times 10 to the 11th power. This number has to be greater than 1 and less than 10. It's always multiplied with a big X. The only time we use an X now in math is when we're doing scientific notation. It's always 10 raised to some power. So this number is greater than 1. Well, it's greater than or equal to 1, I guess. And less than 10, not equal to 10. So 1.8 is greater than or equal to 1, and it's also less than 10. Does that make sense? And then it's times a power of 10. They call it, stop throwing stuff. They call this a power of 10. It's 10 raised to a power. All right? It's always a 10 here. This is always a 10 here. So in this case, this is the number between 1 and 10. The power would be 11. Any questions on that?
No.
Okay. So we're going to learn how to multiply them, and then I'm going to show you how to put them back in scientific notation. So these 2 problems, we are multiplying here. So let's go ahead and write what I'm writing. We're going to multiply and then write in scientific notation. We've got to put our answer back in scientific notation. So when we do these problems, I thought I had an example of this, but let me see. I think I do. Okay. We actually have one right here. So this is the problem. You guys have this on your notes? Okay, so yeah, flip your side over. I must have duplicated that. So these are the notes we're going to get. So what is a simplified form? And this is 1.8 times 10 to the 11th power times 2.7 times 10 to the 8th power. And we have to write our answer in scientific notation. So that's why I wanted to remind you of what scientific notation is. Technically, you should have already covered scientific notation, probably in middle school science, probably also in middle school math. So the first thing that we're going to do is rearrange the factors so that the numbers are grouped together. Sorry, let me redo that. How did I word it? The numbers without the powers of 10 are grouped, and the numbers that are powers of 10 are grouped, and I'm going to show you what that means. So the first thing we're going to do here is rearrange. So I'm going to take 1.8 and 2.7. Those are the numbers without the power of 10. I'm going to put those in a parentheses. Then I'm going to take the numbers that are a power of 10 and put those in the same parentheses. Does that part make sense? The order doesn't matter when you're multiplying. It's like 3 times 5 is the same as 5 times 3, right? If we have 2 times 3 times 5, you can put those numbers in any order you want. What we have here is 4 different numbers basically that are being multiplied, so we can rearrange them. So the next thing we're going to do, we're going to multiply the numbers in the first set of parentheses. So 1.8 times 2.7. And that equals 4.86. So we're multiplying 1.8 times 2.7. That's 4.86. Now we're going to multiply the powers of 10 by adding the exponent. Adding the exponents. And we're not going to fill this one in.
So basically,
So it's times 10 to the 11 plus the 8th power. So this would be 4.86 times 10 to the 19th power. Taviana, you writing what I'm writing?
that's 4.86. Wait. Yeah.
So remember, it says to write it in scientific notation. So at the end, we are going to check to see if it's in scientific notation. In order for it to be in scientific notation, it has to be some number multiplied by 10 to some power. But this number, remember, has to be greater than or equal to 1 and less than 10. Is 4.86 greater than or equal to 1? Sam? Is 4.86 greater than or equal to 1? Yes. So that's a yes, right? Is it also less than 10?
Yeah.
So this answer is already in scientific notation, so we don't have to do anything to that. We don't have to change that around. That would be your final answer. Any questions? So the problem is sometimes when you multiply them, they might not be in scientific notation when you multiply them. So we're going to look at number 40. Y'all caught up with me? So doing your homework with you, number 40 is one of your problems. We'll be down to 22 problems after this. 0.8 times 10 to the 5th power times 0.6 times 10 to the negative 17th power. Y'all with me? All right, so the first thing we're going to do is going to rearrange 0.8 times 0.6 times 10 to the 5th times 10 to the negative 17th. So we rearranged first.
Wait, what? It's 8.6? What's the first one? I thought it was zeros.
Sorry?
Never mind.
Yeah, they put zeros in front of theirs. If you like, I can put zeros in front of mine. I don't typically put the 0 in front of the decimal, but I don't mind doing that. So, there we go. So when we multiply that on the calculator now, we're going to multiply these, and then we're going to use a shortcut to multiply these. So this is going to be 0.48, right, on your calculator, times 10, and we're going to add those exponents. That would be 0.48 times 10 to the negative 12th power. The problem is, what? Does anybody know what the problem is here?
Less than 1.
Yeah, 0.48 is less than 1. So I'm going to rewrite 0.48. So if we're rewriting, we need to write this so it's greater than 1, right? So I'm going to do that over here. So 0.48, if I move that 1 to the right? I'm going to, let's do it this way. Move it 1 to the right, so now I'm going to have 4.8. Does that make sense to everyone? When I do that, I've got to say it's times 10 to some power. Since this number was less than 1, we're going to make that, we moved it 1 space, so it's going to be 1. Since it was less than 1 to start with, that's a negative 1. Jacob, does that make sense? So now I'm going to replace 0.48 with this expression. 4.8 times 10 to the negative first times 10 to the negative 12. So now I need to combine those 10s, but this is greater than 1 and less than 10. Or greater than or equal to 1 and less than 10. Does that make sense, Anaya? Alright, so now I have 4.8 times 10, negative 1 plus negative 12 is 10 to the negative 13th power. Do you want me to give you an example of one where you'd have to do it the other way? It'd have to be a positive exponent? Okay, so I'm not going to do the whole thing, but let's do one where you have to use a positive exponent. So let's say, this is just an example, not one of your homework problems. Let's say we have this expression, 11.4 times 10 to the third power, okay? This number is greater than 1. I'm going to go over here. I'm just going to move the decimal place. Now I've got to move it to the left. This number is greater than 1 now. I'm going to have 1.14. That's got to be times 10 to the something. Since this number was greater than 1, I moved it 1 space, and it's a positive 1 this time. Does that make sense, Sam? So 1.14 times 10 is 11.4, right? Because that's 10 to the first power. But we can't forget we had this as well, times 10 to the third power. So now I still have 1.14, but I'm going to combine, add my exponents here because the 10s are like bases. Very good. So once you multiply these, if it's not in scientific notation, you've got to rewrite it in scientific notation. All right? All right. So we're going to go ahead and go down and do one like number 19. That's what Aiden asked for. Really, all we have to do here is use our calculator. Okay? So we're going to do, not 19, because that's going to be your homework for Monday. Let's do 20.
Wouldn't that be 243? And then the ABC 1, and then ABC 2.
No, this is an exponent, right? So this is going to be on your calculator. So we're using our calculator. So on the calculator, we enter 243. Then we enter our y to the x button. Then we enter parentheses. 1 divided by 5. That's the easiest way to do it, I think. And then equals. You could put that in as a fraction, but you don't have to. 3?
So I got,
Nice. That's the answer.
Yeah.
If that exponent is less than 1, then the value that it simplifies to is going to have to be less than what it starts with. So that makes sense. If you take 3 and raise it to the 5th power, you get 243, by the way. So all we're doing on 18 through 26 is using our calculator, but 24 and 26 look weird. You guys want to do those together?
Yeah. No, yeah.
All right, so let's do number 24. We'll be down to only 20 problems, I think, for you if we do number 24. So 7q raised to the 4/3 power times 6r to the 3/5 power q to the 1/3 power times 6r to the 1/5 power. So let's rearrange it and put all the numbers together. 7 times 6 times 7 times 6. Now let's put the q's together. Times q to the 4/3 plus q to the 1/3 power. I said plus, not plus times. The shortcut is adding the exponents, but we're multiplying the expressions. And now, so we've got our q's, so now let's put our r's in here. Times r to the 3/5 power times r to the 1/5 power. So we're going to use our calculator here. And that'll be 1,764. Now we're going to multiply these by adding the exponents. Remember, we can add fractions in our calculator. Omar, Tavion, sit up please. Tavion, sit up please. So this is going to be q. And do you guys remember how to add fractions on here?
Yeah.
Okay, well let's do it. It's 4 ABC button 3 plus 1 ABC button 3 equals 1 2/3, but we want that as a mixed or an improper fraction. So we're going to hit second ABC, and what do you get? 5/3. Now we're going to do the same thing with R. Well, actually, these have the same denominator. The easiest thing to do is to add the numerators, but if you forget how to add fractions, you can use the shortcut. So 3/5 plus 1/5, we just add the numerators and we have 4/5. But like I said, you can use a calculator, so if you forget what you're doing, use the calculator. Any questions?
no.
All right, let's do number 28. Because you're using the same concept. So 5 to some power times 5 to the 3rd power equals 5 to the 2nd power.
Yeah.
So what power has to be here for this to be equal to 2 if we're adding these together?
1. Oh, negative 1.
Negative 1, right? So it's going to be 2 minus 3. So the trick is 2 minus 3 here equals negative 1. So that's going to be, in here is negative 1. Any questions on 28 through 32? All right, let's flip it over. I need you to write down the formulas for 34 and 36. Yeah, so 34, the formula for the area of that parallelogram is the base times the height. And I'm going to tell you the height is the dotted line. The height is 3n squared. The base is 6n plus 5. For 36, the formula is the area equals the side square, because this is a square. All four sides are congruent. All four sides have the same measure. So, and what is the side measure for 36? What is the length of the side in 36? Sam, how long is the side of that square? 3.
Z4.
Yeah, to the 4th power. So you're going to plug this in for x. Here you're going to plug this in for h. You're going to plug this in for b. Remember, this is base times height. Side squared is side times side. And let's do 44. So we have not done one that looks like these with a fraction. Well, I lied. We have done these, but we're going to do one anyway. N to the negative 8th power times n to the 3rd power. So the premise for this one is we're gonna simplify those n's, and then if it's a negative, we got to move it. If the exponent is a negative, we got to move it. So that's what we're doing here. So 1 over n, when we multiply n to the negative 8th power times n to the positive 3rd, we get to add those exponents. So that's going to be n to the negative 5th power, right?
Yeah.
Now, can we leave that negative expression, that negative exponent in there? So what are we going to do with it, Aiden?
Move it to the top.
Move it to the top. And actually, that's going to leave nothing in the bottom. We don't need a 1 in the bottom. So that's what we would that would be our final answer. Yes. So let's see, which ones did we do? We did 44. We did 40. I told you how to do 34 and 36.
You did 20 and 24.
Good. And we did 28, and we did 20 and 24. And we did we do 14?
No.
Yeah, we did 8 and 14. So I did 1, 2, 3, 4, 5, 6, 7 of your 25 problems. So that leaves you 18 problems, but some of them are pretty easy, pretty quick, right?
Yeah.
All right, so you're doing all of them. So scratch out that part where it says 2 through 14 even and 24 through 48 even, because we're doing all even problems. So that's all the problems, so their numbers are divisible by 2 evenly, right? So right now you're doing work on 2 through 12.
You are appreciated.
You can't the last 10 minutes of class, honey. Sorry. All right, and that was pretty quick, and we had quite a big delay in the middle, but I will post the video.